We're going to look at simplifying rational expressions 19 through 21 and 24. Now 19 is adding rational expressions. Before we can add fractions, we need a common denominator. So in order to determine the common denominator, we can factor this quadratic. This would be x minus 6x plus 3, which makes it clear that this is missing the factor x minus 6. So if you change the denominator, you have to do the same thing to the numerator. So I'm going to multiply by x minus 6 in the numerator. Now I have a common denominator of x plus 3, x minus 6. And in the numerators, I can add the fractions. So this is 3x minus 18 plus 27. Adding like terms, this would be 3x plus 9 over x plus 3, x minus 6. And we can factor the numerator, so this would be 3 quantity x plus 3 over x plus 3, x minus 6, which allows us to cancel the x plus 3's. So we get 3 over x minus 6 as our final simplified answer. On number 20, we're dividing rational expressions. When we're dividing, we are multiplying by the reciprocal. So I'm going to switch the numerator and the denominator on this one. We also need to factor everything before we can cancel. So this will be 10 quantity x minus 4. This quadratic is x plus 5, x minus 4. And this is a difference of squares, x plus 5, x minus 5. So now that I've changed it to multiplication, I can cancel common factors. X minus 5's cancel, the x minus 4's cancel, the 5 cancels and becomes a 2 in the denominator. So we have an x in the numerator and a 2x quantity x minus 5 in the denominator. So number 21 is just one fraction where we're simplifying using exponent properties. So in this case, we're cubing all of these. X cubed, y, 4 times 3 is 12, and then z to the negative third. In the denominator, we have all of these. So z to the negative third is the same on numerator and denominator. Those cancel. Y to the 12th cancels. We have a 5 in the denominator, and we also have an x left in the denominator, which means there's a 1 in the numerator. So the last problem that we're going to look at here is number 24, which is a complex fraction. So we have fractions within a larger fraction. So we can first simplify this expression, 9 minus 1 over y squared. We're subtracting fractions, so we need a common denominator. This is going to become 9y squared over y squared, since we need a common denominator of y squared. And then minus 1. And then if we continue to simplify, we could do 3y plus 1, 3y minus 1, since this is a difference of squares, over y squared. So we've simplified the numerator of this original problem as much as possible. Now if we look at the denominator, the common denominator of this denominator is y squared. So this needs an extra y. This needs a y squared. So we will end up with 9y squared plus 6y plus 1 over the common denominator of y squared. This becomes 3y plus 1 times 3y plus 1 over y squared. So now I have this expression divided by this expression. So if we rewrite that as a traditional division problem, we have divided by this. That means we're actually multiplying by the reciprocal of this. So y squared over 3y plus 1, 3y plus 1. So these common factors cancel, these common factors cancel. So in the end, we end up with 3y minus 1 over 3y plus 1.